Welcome everyone to The Explainer. Today, we're going on an absolutely fascinating journey into the hidden mechanics of reality itself. We're going to explore how the universe, and amazingly enough, our own minds, organize information at the absolute most fundamental level. If you've ever stopped and wondered how physical boundaries relate to the invisible rules of logic, well, you are definitely in the right place. Here is our roadmap for today's journey. We'll kick things off with the core mystery of duality, move right through sets and logic, cross what we call the Boolean bridge, flip the rules, and finally we'll land on perception and cognition. Let's dive right in. Section 1. The mystery of duality, objects versus rules. I want to hook you right away with a pretty profound question. What if objects and the rules that govern them were actually the exact same thing? Usually we think of objects as physical, tangible things you can touch, and rules as these abstract, invisible laws floating out in the ether. But the source material we're unpacking today suggests a hidden connection, a connection that ties the physical world to logical descriptions in a deeply, deeply inseparable way. That specific connection has a name. It's called attributive duality. Simply put, it's the dual relationship between topological containment, which is essentially physical or mathematical space, like sets containing points, and descriptive attribution, which are the logical rules or attributes describing those points. Basically, physical containment and descriptive rules are literally two sides of the exact same coin. Think of it like a VIP club. You've got the physical room holding the people, that's the set, and you have the strict dress code required to actually get in, that's the rule. They completely mirror each other. Where sets contain elements, attributes describe their arguments. Moving on to Section 2, sets versus logic, inside out versus outside in. What's really interesting here is the awesome spatial metaphor this creates. On one side of the coin, we have set theory. Set theory tends to focus entirely on objects, the sets themselves and the elements inside them. It defines reality from the inside out, focusing purely on topological containment. Now, on the other side, we have logic. Logic tends to focus on attributes or the informational boundary constraints that objects have to satisfy. So it defines reality from the outside in, based on those intersecting boundaries that the objects conform to. It is the fundamental difference between an inclusive, flowing collection of items and a sharp, restrictive set of rules. So the absolutely crucial point to take away here is that any containment relationship can be interpreted in two completely distinct ways. First, you can look at it in terms of physical position with respect to bounding lines like point set topology. Or second, you can look at it in terms of descriptive distribution relationships like logical substitution. And here's the best part. Both of these are modeled perfectly through something we all learned back in grade school: Venn diagrams. When you look at a simple Venn diagram, it's actually serving as a grammar for both the physical position of an object inside a circle and the logical description of that exact object's attributes. All right, Section 3, the Boolean bridge, connecting the worlds. So how do we actually translate between this world of physical sets and the world of descriptive logic? Well, the answer is Boolean algebra. This is the unified mathematical structure that perfectly, and I mean perfectly, expresses this dual relationship. It actually proves that the underlying algebra for sets and the underlying algebra for logic are entirely identical. Boolean algebra is the ultimate universal translator between space and rules. And mapping this out brilliantly illustrates exactly how that translation works. In set theory, the focus is squarely on objects, but in logic, it's on boundary constraints. But look at the operations themselves. The set theoretic union, which is combining two sets, exactly matches the logical or, meaning an element belongs to either A or B. Furthermore, the set theoretic intersection, where two sets physically overlap, perfectly mirrors the logical and, meaning an element belongs to both A and B. The math itself doesn't change one bit, only our perspective changes. Which brings us to Section 4, flipping the rules, the power of negation. The real difference between sets and logic hinges heavily on the act of negation. Think about it. Identifying an individual element by constructively naming it X is super easy. You just point at it. It's kind of like finding Waldo when someone is already pointing their finger right at him. But identifying its complement, its exact opposite, is entirely different. It requires applying a restrictive constraint, not X, across an entire finite or even infinite context. You aren't constructively naming an element anymore. You are defining the restrictive boundary of absolutely everything that it is not. And this brings us to a really beautiful piece of math. The duality holding between names and constraints is perfectly captured by De Morgan's laws. By using negation, those little tilde symbols, we can permute the objective and attributive operations of union and intersection. Not A intersected with not B is the exact same thing as not A union B. De Morgan's laws show us exactly how we can seamlessly flip back and forth between constructing sets of objects and restricting the logical boundaries around them.
Part 5. Perception and Cognition, Biology of Math. This is where things take a huge turn. Let's see how all of this abstract math builds directly into human perception. Because attributive duality isn't just about chalkboards and complex equations. It's actually describing the literal mechanics of human cognition. This brings us to state syntax duality. This is the academic principle that cognitive states express topologically, as forms or actual objects in your mind, while the structures of the mental operators beneath them express descriptively, almost like a syntactic language of rules. Information literally requires syntactic organization to even exist in your conscious mind. Here is exactly how your brain processes the world, broken down into two very distinct dual steps. Recognition consists of step 1, an additive acquisition of information. You see a shape, you see a color, maybe a texture, but simultaneously, step 2 occurs, a subtractive restriction of informational potential. To put it simply, by defining what an object is, your brain instantly eliminates all the infinite things that it is not. Recognizing an object is simultaneously adding facts while rapidly eliminating other possibilities. It is literally Boolean math happening right inside your neurons. And that leads us to our final section, Part 6, the constructive filter, nested rules. Think of that Venn diagram again. The source material tells us that the contents of the circles in a diagram just reflect the structure of their boundaries. The boundaries are the primary descriptors. So the interior of the circle, the object itself, is simply an interiorization or a self-distribution of its own syntactic boundary constraint. It's wild, but the objects you see in your mind are really just the filled-in spaces of the logical rules containing them. And this leads us to our final form of duality for today, constructive filtrative duality. Because our minds actively use syntactic layering to understand the world, the underlying levels correspond to syntactic coverings, meaning these underlying logical, syntactic levels dictate exactly how objects are constructed and exactly how information is filtered right into our minds. We construct our reality by filtering it through these deeply nested logical rules. Which leaves us with this final provocative thought. Just look around you right now. Seriously, look at the screen, look at the room, look at the objects around you. Are the physical boundaries of the objects you see truly real, independent things? Or are they just the syntactic logical filters of your own biological perception, just the intersecting boundary constraints of your own mind? It is the ultimate two sides of the same coin. Space and logic, object and rule, world and mind. Thank you so much for exploring this incredible concept with me today. I hope it leaves you as fascinated as it leaves me. Keep wondering and keep learning.